Topic under discussion is confusion matrix in machine learning. The references I use for preparing this topic is as these various books like Machine Learning and Algorithmic Perspective, Machine Learning by Tom Michel, Mastering Machine Learning Algorithm from Scratch, Data Science Design Manual by Skinner, Doing Data Science First Edition. Then I referred these two links also. Googled for these links and I found them to be easier towards datascience.com, one article, and datacom.com, one article I refer. So let us dig into the topic, and our topic is what? Our topic is confusion matrix. And what is the purpose of confusion matrix? Check whether the performance of the algorithm, machine learning algorithm, especially classification, is good or not. So what usually happens in a confusion matrix is we design a square matrix. Okay. So you can see here this square matrix. These are the actual classes and these are the predicted classes. And you can see here that on the diagonal, they will be giving the correct answers. So we can think and connect with them with further diagrams and explanations. So you can represent your results, classification results, if it's a binary classification, yes, no, true, false kind of thing. Your confusion matrix plot will be kind of like this. There will be on the horizontal actual equal to true, actual equal to false, and on the vertical predicted equal to true, predicted equal to false. And then there will be four categories of predictions: true positive, false positive, false positive, false negative, sorry, true negative. Or you can see here much more easier. There is a one category called as true positive, one category called as false positive, one category called as false negative, one category called as true negative. Let us say we are predicting whether this email is a spam or not. What a true positive indicates, email is a spam and it is predicted as spam. So true positive. Email is not a spam but predicted as spam. So false positive. False positive is called as a type 1 error. False negative. Email is a spam but we predict it as not spam. This is called as a type 2 error. We can repeat this once again after this one cycle. True negative. Email is not a spam and it is predicted as not a spam. So what is true positive? Actual spam, predicted spam. What is false positive? Actual not spam, predicted spam. What is false negative? Actual spam, predicted not spam. What is true negative? Not spam, predicted not spam. So true positive and true negative kind of prediction and the actual values are similar. So this is how you will be putting your confusion matrix. So you have actual spam and not spam emails, then you have predicted spam and not spam. So now you know what is a true positive, false negative and true negative. So this is how your actual classes are there, then your predicted classes are there, and you have true positive, false negative, true negative. You can see here some results are there and a confusion matrix is drawn for the result predictions. Here the diagonal values 9644 and 81, these are correctly predicted, while other than the diagonal elements are the incorrectly predicted. Okay, for example, this 23 is incorrectly predicted and this 252 is incorrectly predicted. So let us look at a link here. We want to go further and try to understand what is ROC curve. Okay, the long form of ROC curve is receiver operating characteristic curve. It is used for evaluating the performance of a binary classification algorithm. It provides a graphical representation. So for this, again, we need to connect with this true positive, true negative, false positive, and false negative. We all already know them. Now, how ROC curve is derived is we are plotting true positive rate against false positive rate with different thresholds. So, what is the characteristics of a logistic regression? If the observation predicted is greater than 0.5, then it is labeled as positive. So what we can do is we can select different thresholds between the ranges 0 to 1, say 0.1, 0.3, 0.1. So ROC curve will help us visualize these choices, how these choices are going to affect the classifier performance. So anyways, we are speaking about ROC curve and we are saying that it is a plot between true positive rate and false positive rate. I need to remember what is true positive rate. True positive rate is equal to sensitivity, and true positive rate formula is true positive divided by true positive plus false positive. False negative rather. We also need to understand false positive rate, which will be 1 minus specificity, which equal to Fp upon Fp plus Tn, where Fp is false positive, Tn is true negatives. And you have here this plot, which is an ROC plot, and you can see here, this is my perfect classifier at 1, and this is a random guessing, nothing, and this is the plot of true positive rate against false positive rate, okay, against different thresholds. So what characteristics are being spoken about is you have a gray dotted line, it is just random guessing. You have a purple line, which is a perfect classifier. So where the true positive rate is 100% and the false positive rate is 0%. Now, but we are looking for a classifier that has high positive rate and have low high true positive rate and low false positive rate. So it should go towards upper left corner. So this is what it is. This is my ROC curve. You have one more thing called as area under curve also, and area under curve indicates area under the ROC curve. So if your AUC score is higher, the classifier will be performing better. So I'll stop here at this